All right, hey guys, today I'll be solving one of the meta tag questions on Leetcode, most frequent tag, and I will also try to do the variant, aiming for 20 minutes today with the variant, dry run, code improvement, and anything else that would be needed. Right, once I paste the questions, I'm going to start my 20 minutes. So let's go do this. And the question is, whoops, not this one. All right, so we are given a string of integers and a window size. Calculate the moving average of all integers in the sliding window. We have to implement the class moving average and initialize with the size of the window size. Okay. And then double next returns the moving average of the last size values of the string. Okay. So I guess if we are given a string of, let's say, 1, 2, 3, 4. Um, is it like we have to find the moving average of maybe, let's say, of size 2, and other one is input format would be a list of integers, and output we're giving input would be float average number for that string. Okay, so like how much can the size be? The size range would be a question, and also for the next like values here, what would be the value range? And there will be only also in this one, are we given all the values right away, or they come when called? Okay. So size range would be from 1 to, let's say, 1,000. I guess one edge case would be what if size is 0. Um, can be an assumption to just return 0 because values could be hmm, for this, are they positive or negative? So here it could be both, and range could be negative 10 to the power of 5 to 10 to the power of 5. Okay, so we implement class moving average, and I'll just do like some base object is equal to moving average, and like to test we will just call like dot next and pass in maybe size and val. Okay, so we have to initialize the size of the window, so I can just do in like the init, and then we will have a function that returns the moving average of last size values of the string. Okay, so let's say this is our stream right now. When 1 is added, good. 2 is added, Now, if a function called next is called, then we have to return 1 plus 2 over 2. But let's say the size here is equal to 3. So right now we are good. So we'll return whatever values from here, and then let's say 3 is added. So, and then the next function is called again, and then we will return an average. So I think it would be a list of values, right? So on how many times it's been called. And so now we'll return 1, 2, 3 over 3. 3 over 3. Like this way. Okay, now what happens like if we add 4? So we will have to remove this. So one option could be we could just treat it as an array and then remove this element, but that would be like a O of n removal. We can do better. Um, can use a queue because of like FIFO one. So if this is the first gen, then it would also be the first out. So now we just remove this and then give the average of this 2, 3, and 4 for the remaining one. Okay, I'm gonna like just define next. And here we're given, let's do self, and we are also gonna get like value, right, which would be an integer, and this function should return float. Here we have to initialize size, which would be integer. Okay, so here that dot size is equal to size, and we also mentioned that we're going to use a queue, so self.queue is equal to deque actually. Let's just import it from collections, import deque, and this is deque. And we just, yeah, and one thing that we also need to worry about is, let's say, if the current like sum is 1 plus 2, that's 3. So here it was just 1, then there was 3, then now it will be 6. So that will be the window sum, right? So if we have this, we would not have to like go again and calculate again and again. So we can maybe have like a window sum here, which would be initialized to 0. And now, so whenever like this function, like a new element is added, then we will do plus equals value, right? Because that is how our window will expand. And we will also append this value to the queue because this is a new value dot append. Wow. And right now this is good. And we have to return um self dot window sum over self dot size because that would that is what actually it won't be self dot size, right? Like because queue can have like 1 or 2 element, like basically elements length can be less than 5. So we will just do q, yeah, and we'll just take the length of this. All right, and now for example, like if len of q self q is greater than self dot size, then we have to pop from the queue but also remove from the window zone. So removed would be self dot queue dot pop left because that's we are adding from the right, and we'll just once we pop it, we have to self dot window minus equals removed. So right now the window sum would be of what we expect in that window. Okay, I think this should solve it. This is size of the data stream and keep track of the current window. This return the average. Let's do a quick dry run. This one will only get in value. We have to pass in size here. And then whenever we like call this function, it would be okay. And let's say we just do a quick dry run. So we have size initialized as 3 and queue is empty right now. And window is 0 right now. Right now, if this won't execute when we call our next function, so we'll just add in value here. So let's append value of 3 and then we call next, and now it should, right now this is not true, so we don't have to remove anything. Our window sum would increase to 3 and Q already has appended 3 there, and we'll do 3 over 1, which would be 3 as it would return. Yeah, I think that is how it should go. I think I forgot to like start the timer, but this is one of the questions. And then a follow up, oops, variant for this would be what if like, so here we are given the list of integers same and then integer size. We have to compute the average of elements in a sliding window of exactly size elements. So for example, if we have this 1, 2, 3, 4, 5, and 6, and let's say size here was equal to 5, then we should not return like if it was only one element or two element or three elements. It needs to be a window of 5, so all 5 elements. We don't have to have like a live stream of data. So in this condition, what we can do is we can start here and like keep on increasing, and all of the data is given, and data is given right away. Wait, so left and increase it till the size, so that would be till 5, so that would be the right pointer. Now we can make it get the average for this average, and then open. This would be the breaking condition, so now we remove this from our window and then get the average for this second one, and this becomes a sliding window problem. So here, if we do define get window sum, so we are going to be passing nums as a list, of integers and size as int, and we have to return a list of integers with all the, so here the answer would be, first part would be 1 plus 2 plus 3 plus 4 plus 5 divided by 5. And the second part would be 2 plus 3, 3 plus 4 plus 5 plus 6 over 5. This is how we need to return the answer. Yeah, we can just show answer is equal to this and return answer. And now we can have like a left pointer here, and for right in range, len of nums. So we can check the window size while if right minus left plus 1 is greater than size, then we move the left pointer equals 1, and also window sum is equal to window sum plus equals nums at right. And this would be window sum initialized to 0. This would keep track of the. Oh, so if we have this 1, 2, 3, 4, 5, we have a window sum, then we'll know exactly at this right position what it is. And then we will go ahead and remove it, right? So window sum minus equals numbers at left, and then we move the pointer forward. And for the answer, if right minus left plus 1 equals size, then answer dot append window sum over k, and this needs to be a float window sum over k. Sorry, that is size. So this here the time complexity would be O of n, and space would also be O of n worst case scenario, because if what if like um size was like 1, right? So every element worst case would be this. Also, I think one edge case here could be considered if size equals 0, just return like empty list or something. And if I do like a quick dry run for this approach, it would be, let's do this. And we can have this example again. And let's do size equals 5. Actually, I think this should be good enough.